Hello everyone, in this video we will see together how to use temperature force maps with the NanoFrazor. Temperature force maps are especially useful when we're dealing with new materials, when we want to see how the NanoFrazor can pattern at different forces at different temperatures on, let's say, new materials usually. Or it can also be helpful for you to identify good ranges of parameters for temperature and force for your specific samples, even with PPA. So before starting the video, I would like to redirect you, in case you haven't watched yet, to the video that's related to temperature maps, to understand what is a temperature map and why it's needed and how to use it. In this video, we will discuss about the specific case of a temperature map that is used together with a force map, which is a standard design that we import in the NanoFrazor. So it's good that you know how a temperature map works. But let's dive into this specific case. So temperature force maps, basically we see here, we have a design with 10 by 10 squares. This design will be first imported as a force map, and then on top of it we will apply a temperature map. So basically the force will increase from left to right, and then the temperature accordingly will increase from bottom to top. So this is quite useful because then it will help us understanding where we start patterning. For example, looking at this temperature force map, we can say, well, with 1.5 volt at 700 Celsius, we're not able to pattern on this polymer. But if we increase the force at 700 Celsius, we see that at 9.5 volts, then we're able to pattern. So this will help you drawing conclusion for your specific applications. And here we also have a step-by-step guide. It doesn't work any differently from temperature map. So what we will do is we will go to the geometry tab, we'll import grayscale squares, and then in the geometry settings we will add the minimum and maximum depth values so that we can have a equal force gradient. In this case, we want to have a force gradient, let's say from 0.5 to 9.5, and then we add this to the layout, and then we open a temperature map and we create the temperature map from our file. And we suggest here for initial evaluation to use a large temperature range, so from 500 Celsius to 1400 Celsius. And then after we added the temperature map to our force map, we just have to go to session and select the temperature map from the settings. For the forces, we specify the range. So for initial evaluation, we suggest a large force range from 0.5 to 9.5. So let's see how this practically translates into reality. I import, by the way, this temperature force map geometries are in the geometry panels in the geometry folder in NanoFrazor package geometries. So we have a 10 by 10. I see 10 by 10. Okay, in this case we have a 10 by 10. Okay, this is the import. We want to remove any rotation, and we also want to remove the white pixels. This is quite important. So as we were seeing here, for the depth range, the depth minimum versus maximum values should not be equal to allow a force gradient, right? So this is quite important. You can put any sort of value, because in the end, as we write here, it's not important, since the pattern depth is only determined by the force range that we specify later. So now we have 10, 32. It's okay. We can also put 31, 32, right? It's yeah, it's just a gradient, right? So we'll just do our 10, 32, and this will of course create this gradient. If we put 31, 32, everything is pretty much at the same height, so we only see almost one color. We like this design, we import it, and then we go to our optional tool, and we select our last imported field. Then I select this again. We ignore the white pixels, and we see that we have our temperature map that we can spawn, let's say from 500 to 1350. Alright, so basically, as we increase, in this case, the color from left to right, we're increasing. If we want, we can also import another design in case we want a slightly different increase of direction for the increase of temperature. Here we increase it from left to right. If you want to increase it from bottom to top, we should import this one, which is pretty much what we saw here. So in this case, we increase from bottom to top and from left to right. Here we see we increase from left to right the force. So it's okay. It's pretty much what we wanted to reproduce. And now I resize it to target field, and I add it to the target field. So now this field has a temperature map attached. I go to the session. I select a specific design. What's important also to specify now here is disable the feedback and put a range of forces from 0.5 to 9.5 volts. Then we select the temperature map. And for the scan height, maybe we can put it a little bit higher. In this case, I'm using a sample that's a bi-Richthof sample. So we have 30 nanometers of PPA, and below we have 100 nanometers of PMMA. Maybe the patterning is not going to look as expected the deeper we go with a temperature force map, because we will probably pattern into PMMA, but we can see how it looks. We also see that because we're using the temperature map, and of course the temperature is blocked here, and we will use the temperature value that is within the temperature map. So I would say now we see the results. I'm not sure about the quality of the tip. It's not so good, so we may also have we may struggle in doing the patterning, even if we're dealing with some squares, but apparently not here, even if we're at very low temperature. But once you have done this process, we are already doing a temperature map, so we should already be good, as the purpose of the video is to show you how to use a temperature force map, maybe not to pattern a below sample, but to pattern on new materials, especially. It's something that you can consider, let's say, if you want to change the properties of materials or induce some phase changes or any other interesting applications that you have in mind. And we see that we're increasing the temperature from, let's check again, from 500 Celsius to 1350. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares. So pretty much every 100 Celsius we have a temperature. We see that with 500 Celsius we're only able to make some small indentation, but at around maybe 600 or 575 we're already patterning. Well, here we start patterning deeper and deeper. In this case, we're probably already above 1000 Celsius, and we see that we are patterning. We're patterning already deeper than 70 nanometers. In this case, we're already patterning in the underlayer because we only have 30 nanometers of PPA on top. And we also set the scan height to -60, which means that probably here we're already not reaching the bottom when we're reading. So at some point we will not see much of a difference now in terms of depth. So probably now for this next set of squares, we will see that they're all from here the same darkness, which means that they're all at the same depth. But what we really expect is that the depth increases along with the force. So this is pretty much as expected. I hope this was understandable and that this tutorial can help you in being effectively test NanoFrazor and TSPL with new materials, new applications, and see what's the impact of temperature and force on such structures. So thanks for watching. I'll see you in the next videos.